All right. When you look at the next question, we are going to do a couple of things with it, okay? The first thing we are going to do is discuss the shape with which we are going to be dealing, all right? Now you look at the question, you read the question, draw and calculate the surface of a rectangular pyramid. So that's the shape that we are going to be dealing with, right? Now, when you see that and it says draw, some of you get stressed. This is not an art class. If your drawing of three-dimensional figures is bad, that's okay. I'm not going to lose a lot of sleep over it. But we are going to draw this. So if it's a rectangular pyramid, what does it look like on the ground? It's going to be a rectangle, right? So we got to draw a rectangle. But since it's three-dimensional and we only have 2 dimensions on our paper, we got to draw it. And I'm going to draw it much bigger than it needs to be drawn. We got to draw it this way, right? Because I'm going backwards. Everybody cool with that? This is going to be 32 because it's the shorter length. And this is going to be 48. Is everybody cool with that? Why have I only shown 2 sides? Because if it's a pyramid, we won't see this part, will we? The dotted line is the back of the pyramid that we don't see. Everybody cool with that? But of course, in reality, we know that you can't have a pyramid without something that it sits on. Cool? Okay. So now we got to draw the walls. The front wall is that triangle, yes? Everybody agree? Oh, it'll show up in a minute. There's just some lag. Nope, it'll die. So we'll reconnect. And we're back. Everybody cool with that being the front triangle? All right. And the side triangle will go like that. Everybody okay? Okay. So now I'm going to erase these dots, because that's what our pyramid looks like. Cool? All right. Now, if I want the surface area, I want all the shapes on the outside, yes? So what is this pyramid made of? There's how many triangles, Sean? 4. 1 on each side, right? So there's 4 triangles. Are they all the same triangles? No, why not? Wait, don't tell me. It's been 4 days since I've seen your names. Don't tell me. No, you're not Josh. Josh sits there on my other block. You're Andrew. Adam. I had the A. Reimer. See, I got last name. Damn. I had the A. Andrew, why are they not 4? I just did it. Adam, why are they not the same 4 triangles?
Because there's like different widths and lengths.
Yeah, because the bottoms are different, yeah? So, I'm going to do something that I like to do. Maybe you guys don't, but it will help you see what's going on here. I'm going to take my red pen and I'm going to shade this side red. So I have a red triangle. Is everyone cool with that? Mm-hmm. And I have 2 of them, don't I? Because I have 1 on each side. So I have 2 red triangles. I'm going to shade the front of it blue. So I also have 2 blue triangles. Cool? And then the bottom is just a rectangle, right? So I'm going to make that, I'm just going to draw that in black. Everybody okay with that? Mm-hmm. Now, if you look on your formula sheet, you will see that there's a formula for a square-based pyramid. Is this a square-based pyramid? No. So that formula won't work here because this is a rectangular-based pyramid. And guys, I'm going to tell you, I'm doing this question now at the beginning of the block because to do this properly the first time actually takes a long time. This is the hardest surface area question that I can give you. Okay? Not that it's difficult, it's just got the most work involved. Everybody okay with that? Okay, so let's carry on here. So you guys are smart kids. What is the area of a triangle? Who remembers the formula? If you don't remember it, you can always check on your sheet. Base times height divided by 2, right? Now, the problem for you guys is, remember we talked about the word base? And it means a lot of things, doesn't it? Right? When I stand up, my base is my feet, yes? So if you were to measure my height, you would go from the base, my feet, up to my head, right? If I stand on my head, is my base still my feet? No, but my height is still from the bottom up. Everybody cool? All right. So in this case, a triangle, we say base times height. So don't write what I'm about to write. But right there, you're going to want to call that the base, aren't you? Because it's on the bottom. Everyone agree? But if I turn that triangle over, the base is now up there. But we would still call it the base. Is that cool? Everyone's okay with that? All right, because that is really important to what we're about to do here. Remember, base and height and length and width are only names that math guys have given to shapes so they can tell the sides apart. It doesn't matter where we turn them, we still call them length and width and base and height. Everyone okay with that? It's kind of like if you saw me on the weekend, I'd be wearing jeans and a t-shirt. I'm still Myers, even though I look different. Cool? When you graduate, you will try to call me Mr. Myers if you see me out in the world, and I will say, no, you get to call me Matt now. I've been teaching for 17 years. There's like 3 kids in the world that are actually able to call me Matt when they see me out in public. When I play rugby with guys that I coached here, they still call me Mr. Myers. I'll be running down the field, and they'll be yelling, Mr. Myers, for me to pass to them. We're playing rugby together in a men's league, and they still can't, right? They're 21, 22, 23 years old now. We are drinking beer, and he's like, hi, Mr. Myers. Oh my God, you can call me Matt. Anyway, sorry, another story for another day. So, I got 2 red triangles. Now, L tells us that a triangle is base times height divided by 2, right? And I got 2 of them, correct? So, I got 2 base times height divided by 2. Hey, wait a minute, what do I get to do with those 2's? Cross them out. So I really only have base times height, don't I? And then what do I get to do with the blue one? Same thing. Base times height. And the black is length times width, yeah? Now you guys are smart kids. You already know the red triangle's base, don't you? What is it? 48. We got it written right there, right? So we know this is 48 times a height. And what's the blue triangle's base? 32 times a height. And the black triangle is 32 by 48, right? Because it's length by width. Now here is where every one of you is going to make your mistake. What's H? The height of the triangle itself. So what is it? Of course you have to calculate it. But the question says it's got a height of 65. Why did I write it that way? 65 is the center straight up, isn't it? Right? If you measure your height, you go from the middle, straight up the middle to the top of your head, right? You don't go up the side. Because if you did that, my height would be like 6'4". I'd love it if that was my height, but it's not. I'm 5'8". Right? Okay. So now the question becomes, how do I get this height up the side? Because right now, I know this height, right? Down to the middle of the bottom. How tall is that? 65, right? And how far is it over to this edge? Why is it divided by 2? Because I'm in the center and I'm going across. Is everybody cool with that? So that gives me this triangle. 65, 16, and that's going to go up this side, isn't it? Well, Kirsten, the height goes straight to the middle of the rectangle down here, yeah? Then I got to go out to the side, don't I? And all the way across this side is 32. But I'm only going half. You cool with that? That's why this is the hardest question. When we're talking about it, it makes perfect sense, doesn't it? But it's yucky to draw. and it's yucky to write. So I have this triangle, yeah? 65 down, 16 out, and that's going to give me this distance up this side, yeah? What math do I do to find that? It's Pythagoras, isn't it? So it's the square root of 65 squared plus or minus 16 squared. It is a squared plus b squared plus c squared, but 65 is the a, isn't it? And 16 is the b, isn't it? So is it plus or minus here? Plus, because I'm looking for the hypotenuse, yes? So when you do that on your calculator, because everybody's calculator works differently, you're going to get a number. Everybody cool? And that number is going to be the red triangle's height. Is everybody all right with that? So everybody go ahead and use your calculator to find the red triangle's height. Give it to me with 2 decimal places. If you don't want to practice or you're comfortable using your calculator, that's fine. I got to check. I don't remember. 65 squared plus 16 squared square root. I get 66.9. 0.94. Is that what everybody else got? Depends on your calculator. That big giant one, for you need to push. Oh, here, I can show you right on the screen because I have that. So for you, Brianna, you can actually do all of this in one shot. Okay, yeah. But it's a little tricky. So I'm just going to do this step by step. Okay? So what you had was 65, then you hit the squared button, right? Yeah. Then you added, hey, Mr. DeVries, 16. Cool, thanks. 16 squared, then you hit enter. That gave you this, right? Now, to square root that, your calculator will do it. Second function, x squared, and you'll get a square root sign, right? And then you just can punch in 4481. There's other ways to do it, but that's kind of the easiest one. And then enter, and you'll get 69.94. Everybody got their 69.94, right? Okay, now, that covers the red side of the triangle, yes? Everyone agrees? But we need the blue side, don't we? Right? So what's going to be the same on the blue side? The 65 is going to be the same. I'm still going to have 65. But what's my other number now? It's this one, isn't it? Which is what? 24. Then I do the same thing, don't I? So what do I get for the blue? Practice it yourself. It's going to be 65 squared plus 24 squared and square root that. And I think that number is like 69.3 or something, but I can't remember. What was it, L? 69.29. Everybody cool? Everybody understand? So now I got a red H. So where does that go in my equation? Goes right there. Cool? And my blue H goes right there. Now when you've practiced this a lot, you can do this all in one shot. But how many of you feel so comfortable that you would try doing this all in one go? A couple of you maybe. But I really recommend writing it out, because look how much we were able to simplify by writing it out without any numbers. Picking up what I'm putting down? Then you just punch this into your calculator and add it up. I can't remember what the answer is, but you guys can figure that out. You've got 66.94 times 48, 69.29 times 32, 32 times 48, and then add it all up. And that'll give you your answer. Now the point I'm trying to make here is this question required a lot of work, didn't it? But the work that it required is all stuff that you already knew, right? You already knew Pythagoras. You already knew length times width. You already knew base times height. You already knew that pyramids are made up of 4 triangles. You picking up what I'm putting down? So where is the only thing that you really had to think about in this question? This. The height being 65. That's the problem, isn't it? Because when you hear height, you want to put it in everywhere you see an H. If you are just memorizing formulas. Do you see the problem? This is why you gotta draw stuff out, even if you draw badly. Or you gotta write it out. Is everybody with me? Okay? Remember, height is not ever the measurement up the side of anything. Everybody cool with that? If you need a measurement up the side, you're gonna need to do Pythagoras every time. Cool? Everybody okay? Now remember, this is the hardest question I can give you. That's why I'm giving it to you in class when we can talk about it. Your job is to figure out where in here you're screwed up. Because I can't help you if you can't tell me where you are. Is everybody understanding of the fact that we have 4 different triangles? Is everyone okay with that? And everyone is okay with my canceling here? Is everyone okay with that? Because I had 2 times the triangles. 2 over 2 gets to cancel. Everybody's all right with that? Yeah? So the biggest problem, I'm sure, for everyone was the Pythagoras, yes? Because that requires you to get your mind around something. Yep. No. No. Because the 2's have canceled. That's my girl. That's my daughter. I have to take her to Vancouver by 5 o'clock today. She was in a movie. It's being shown. She's not just a midget grade 10. She's not a midget student teacher either. Man, boy, wow, they're letting him in early into college. Anyways, it was a school for Vancouver Film School. It wasn't a big deal. Although she was in Love Punjab, in case anybody saw that. Well, why would you? Although it was one of the biggest Indo-Canadian movies ever. She was in that. Everybody cool? You're going to get practice with it. Stay calm. The point of it all is don't forget Pythagoras. If you need up the side of anything that's a peak, you're going to need Pythagoras. Okay? All right. So let's look at the next question. The next question says, draw and calculate the surface area of a cone. All right, well, a surface area of a cone, you know it starts with a circle on the bottom. And we got to draw it kind of squished because it's 3-dimensional. And since it's a cone, it goes to a point. Everybody agree? Everyone's cool with that, right? You guys are smart kids. Surface area is everything on the outside of a shape, yes? Well, what's on the outside of this? Part of it's real easy. What shape is that? So we know that a cone starts from a circle. What's the area of a circle? Pi r squared. We know how to do that. We learned that in grade 8, right? But there's more to a cone, isn't there? The rest of a cone is this. A quarter of a circle that is rolled together. Now this is a tiny example, but all of you should be quite comfortable in seeing that gave me a circle on the bottom, didn't it? Right? There's my pi r squared, right? And then I got to somehow figure out this area. Yeah? Everyone agree? Okay. Well, you guys are smart kids. To do the area of any circle, what do I need? I need a radius, and I need... Pardon? I'm going to need a height. That's in a cone. But I'm going to need a radius, and what else? Not for area of a circle. Pi. I'm going to need pi, right? So I know that to deal with this, I'm going to need the radius, and I'm going to need pi, aren't I? Everyone agree? Okay. Now here's where it gets tricky. In a circle, it's pi r squared, isn't it? Okay. You guys are smart kids. Once I tip this up, that r becomes the side, doesn't it? Right? So I also have to add pi r, but it's not r anymore. 1 second, don't tell me fa. What do you need? You going to tell me the answer? Of course. Pi r s. Okay? And that s is the slant height. Now, guys, I need you to understand this. The slant height is up the side of a pyramid. And what did we just discover on the last question? When we needed to find the distance up the side, what math did we have to use? Pythagoras. So slant height, if we need it, we must use Pythagoras. Now you will notice I am not calling Pythagoras a squared, b squared, c squared. There's a reason for that. I don't like teaching it that way. Because when we do a squared, b squared, c squared, as soon as I change the letters around, kids screw it up. So I call it Pythagoras. If we need it. Now, let's look at this question. Pi r squared, pi r slant. This is another new thing for grade 10. I'm going to put a star there. In grade 8, grade 7, when you started working with pi, what did you use? 3.14, right? Then hopefully your grade 9 teacher said, guys, we're in grade 9 now. We're going to start using the pi button. You all started using the pi button last year, didn't you? Everybody cool? Now, we aren't going to use the button even. We are going to leave pi as pi. Okay? So, this is new. I've got pi. Do I know my radius? Yeah, read the question. Radius of 15. So 15 squared. Is everyone cool with that? Okay. Plus pi again. We're going to leave it as pi. Radius 15. Now my slant height. Do I have a slant height? No, I don't. So what would I have to use right now? Pythagoras. I don't want to use Pythagoras right now because there's a reason. What I want you guys to do is right here, write the word slant. Let's pretend we do have a slant height. My slant height is 22. So what goes in here for S? 22. Is everyone cool with that? Now, in grade 9, in grade 7, we would do 3.14 times, wouldn't we? In grade 9, we would use our pi button. In grade 10, we are leaving it alone. So what is 15 squared? If you don't know, you would go to your calculator and do 15 squared, which is 225, right? So I get 225 pi. Cool? And 15 times 22 is what? 330 pi, yes? So now I have 225 pi's and 330 pi. How much pi do I have? 555 pi. That is what we want in grade 10. Does everyone understand? We don't want the decimal. Unless you happen to be writing a test that has decimals, then you would finish off with one last step. Okay? Is everyone cool with that? I want you to leave pi as pi. Everyone okay? All right. Now, if we didn't have the height, if we had this height was 22 and this radius was 15, then what would I do to get the slant? I'd have to do Pythagoras again. Everyone cool? I didn't do Pythagoras because I wanted it to work out perfectly. I didn't want you to have any decimals. Everyone okay? All right. Let's go on to the next one and see what happens. Draw and calculate the surface area of a pop can. So a pop can has a circle on top, a circle on the bottom, and goes up the side. Now you guys are smart kids. Surface area of a pop can. The top's what? What shape is the top? Circle. What shape is the bottom? So I have two circles, yeah? So it's 2 pi r squared, correct? Okay. That covers the top and bottom. What's the middle of a cylinder? A rectangle, right? Yeah? What's the area of a rectangle? Length times width. But once I put it into a cylinder, you don't want to say length times width anymore, do you? Even though it is length times width, right? But once I make it a cylinder, the length becomes this, right? What do we call that in a circle? The circumference. And the circumference of a circle is always, no, that's degrees. It's always 2 pi r, isn't it? So we need to add the length, which is 2 pi r, right? And what would you call this measurement now? The height. Because when it's a rectangle, oh, that's width, Mr. Myers. But as soon as I do that, oh, that's the height now. It's the same thing, isn't it? Now here's the problem. As I hold this up, you all say this is the height, correct? What if I do that? Now what's the height? You want to call it this, right? But isn't that the diameter? Where is the height? Here. So what is it now? It's still here. Does everybody understand? That's why learning the formulas is really bad. You understand what I'm saying? Right? Because if I turn this, what if I turn it that way? Now what's the height? It's still this measurement, isn't it? But if I make this like a slide on a playground, you know those tube slides on playgrounds? You would say that the height was here, wouldn't you? You understand what I'm saying? If I'm standing here about to slide down, I have a height. I'm above the ground. But it's got nothing to do with this, does it? It's all this measurement. Does everybody see what I'm saying? You can't learn the formulas. You have to learn what we're talking about. Okay? So, what do we know about this here cylinder? Well, we know its diameter is 10. This doesn't call for any diameters, does it? What do I need? I need radius. So what do I do to diameter to get radius? Equals diameter divided by 2. So that's 10 divided by 2 to get 5, right? Do I know the h? What is it? 20. So now I can just go to my formula and fill it in. 2 pi 5 squared plus 2 pi, what's r? What's h? 20. Are we going to do anything with those pies? No. What's 5 squared? Times 2? 50 pi. Everybody okay there? Everyone okay there? What's the cheapest concert you can go see?
50 cents.
Shut up, you know the joke.
No, I
So do you.
No.
What's the cheapest concert you can go see?
No. Can I say the full one?
Yeah, go ahead.
50 Cent featuring Nickelback.
50 Cent with opening act Nickelback. Because it only costs you 45 cents. But it doesn't. Because first of all, you wouldn't even spend 45 cents to see that show. Because both those bands suck. Well, the band sucks and 50 Cent sucks. So. Huh? You're entitled to that opinion. You know how I feel about opinions. You're all entitled to them, even when they're wrong. Of course my opinion can be wrong. I have no problem with my opinion being wrong. That's the big difference between being a grown-up and a kid. I'm okay with my opinion being wrong. And when other people think my opinion's wrong, I'm okay with that too. Everyone's entitled to an opinion. They don't have to agree with yours. Which is why I get so bothered when I see people angry on Facebook. Why do you care? Plus, what's 5 times 20? Times 2? So I got 200 pies there, yeah? What's the answer? 250 pi. Now, let's pretend you're writing a test for somebody else, and that answer isn't there. All the answers have decimal places. So then you just convert it. How would you convert it? Pi is almost 3, isn't it? Right? So 250 times 3 is 750, right? So whatever choice is around 750 is the answer. Cool? That's pretty awesome. We're going to have a day off tomorrow. We might have a day off Friday. Then, of course, it's a long weekend. That's what I said. Family Day is Friday, is Monday. Of course, you all know what is really going to happen. You're going to have tomorrow off. You're going to have to come back Friday and then not come on Monday. That's what's really going to happen. Did you guys see that thing on Facebook where there's the cops walking away with a woman dressed in an Elsa dress in handcuffs? Like, oh, we finally caught that bee. No more snow. It's a funny picture. Yeah. There's one. Did you guys see on ABC News, American National News, some idiot in Chilliwack that was snowboarding behind his car?
I saw that in Abbotsford.
Yeah. He was tied to a car, and he was snowboarding down the street because the snow in Chilliwack is crazy. Yeah. I saw so many people cross-country skiing with their dogs.
No way.
I know, it's so lame.
Are you joking?
No, not joking at all. All right. Is everybody cool? Okay, now, just wait a sec. There's one other thing I need to show you because you guys should have a bunch of blank space now. No, you don't. You have very little blank space. All right, I need to remind you of something before you go on to your assignment, which I don't think I actually printed for you. Oh, it is printed for you. Sweet. Okay, before we go on, I need to remind you of something from the 9th grade. Okay? Cube, yes? Mm-hmm. That cube is 1 by 1 by 1. Everyone okay with that?
Yep.
So what's the surface area of that cube? No, that's the volume. The surface area of this is 6. Let's call it centimeters squared, right? Right?
Yeah.
Everybody cool? Mm-hmm. Okay, now, if I draw another one, that is 1 by 1 by 1. What's that surface area? 6. Right?
Yep.
What happens if I put them together?
You've got...
Do I have 12? No. Why not? because I lose that,
Yeah.
it would be 10.
Yeah.
I lose that twice. Everyone remembers this?
Yeah.
Okay, just I'll show you. I'll show you. It's the overlaps, right? Everyone remembers this? Everyone remembers this, yes? Cube, 6, right? 6 sides. 6. When they're apart, 6 and 6, the surface area of all the cubes in my hands are 12, yes? But when I do this, I lose this face and this face. So I lose, yeah, it's exactly. When people put 2 tables together in a restaurant, you lose this seat. And you lose it on both tables. Everybody cool? Remember, your overlaps disappear twice. Okay? I'm going to give you guys a real big hint on this. Before you think about your overlaps, simplify your math. Okay? Here's what I mean by that. You know this has a formula. You know this has a formula. Before you put any numbers in or think about overlaps, you can take those out before you do any math. Understand? Right? Because this guy is 6 times length times width, right? And the other guy was 6 times length times width. But you know you're losing 1 from both sides, aren't you? So it's really 5 length times width plus 5 length times width. See how all that's disappearing? Thank goodness for my expensive computer. So it's really 10. I can't even keep up with how fast it's disappearing. Everybody understand? Do you have to do that? Of course not. Can you do it? These like you did in grade 9, figure it all out, figure out the other one, figure out the overlap, subtract it times 2? Yes, it's just more work. I don't care how you do it. Everybody cool?
Yeah.
Now, the next thing I'm going to remind you of is this. Your assignment page has every measurement that you need on it, which means you may have to use those measurements to find other measurements. Understand? Everybody cool? Okay. Do that sheet. I think you have 2. It's 1 page front and back. Is it not, Emily? Just front.
Yeah.
Okay. Do that. It is due the next time I see you. And the next time I see you, you have a quiz on measurement. Okay? I think that the next time I see you will be Friday. I think. But I might be wrong. So do not go home tonight and say, oh, we're not going to school, Mom. I'm not going to do this. Okay? Assume you're coming to school tomorrow until you know otherwise. And then once you know otherwise, you won't have done it anyway. You'll be like, I knew I wasn't going. Cool? Go. Yes.